Greetings. I am Chris Oswalt, and with me is Rene from ACT-GEO, Brandon, Professor Brandon Harper, PhD, genius, and we're going to be talking about incised valleys. So Rene is going to go over some concepts. Brandon's going to look through a 3D model that we got from Ireland, and we're going to look at this a little more in depth. So with that, Rene, go ahead.
Thanks for the intro, Chris. Yeah, so what we thought we'd do is a little video using one of our outcrop models and discussing a geologic concept, in this case, incised valley fills with the three of us. So see what you make of it. So just to kind of set the scene here before we go and look at a model of a candidate incised valley fill is that, why are we doing this as well? When we build sequence stratigraphic models based on depositional sequences, sequence boundaries are really the fundamental building blocks that separate out sequences. So identifying sequence boundaries is one of the most important things you can do in your subsurface data, whether that's cores, well logs, or seismic data. And one of the key kind of helping identifying criteria, particularly when you're on the top set dominated part of depositional sequences, is to look for what is called incised valleys. What an incised valley is literally just that. It's fluvial systems, as shown in this cartoon from a publication that kind of discusses the method, that are incising, so they're cutting out stratigraphy and then they're being filled with fluvial sediments. So a key recognition criteria, therefore, for a sequence boundary associated with an incised valley is basal truncation and onlap on top of that. And then associated with that in the deeper water, we would have a potential low stand fan deposited on top of that sequence boundary. So it's a really powerful service to try to identify in your making of a depositional model in here. So what we're going to do is look at kind of the ways to identify these incised valleys and these sequence boundaries. So when do they form and when do they fill? So these incised valleys, and again, the incised valley is associated with a sequence boundary, forms at relative sea level fall during the early part of a low stand systems tract, where shorelines will prograde beyond the shelf break, rivers will incise, and you get subaerial erosion and sediment bypass in these incised valleys. That sediment will deposit potentially a low stand fan into the basin. And at the same time, slope canyons may form that connect the fluvial systems into the deep water. At this point, your incised valley is being formed, but not really being filled. The fill happens really during the later part of your low stand and in the early transgressive, where as sea level starts to rise slowly, and the submarine fan deposition ceases, I might start building a little low stand wedge, so I'm re-establishing the building of a typical clinoform, and at the same time I may backfill the incised valley with originally typically coarse-grained, often braided fluvial deposits, and ultimately more estuarine and marine influence deposits in there.
So, is there a typical facies stack associated with an incised valley fill?
Yeah, well, that's a good question, Chris. Yes and no. So as always, you have to be careful with models of incised valley fills, but there are some general motifs of incised valley fills. So a really good paper, if you haven't come across it, is Ashley and Sheridan 94 that talks about numerous different shapes and sizes of incised valleys and their typical fill. But very often, incised valleys, they are kind of associated with fairly significant erosion. So we're typically talking about things that are, hundreds of meters of fill and kilometer scale width. Very often the basal part tends to be more fluvial dominated fill. And as you go up and sea level starts to kind of backfill into the canyons again, we often get what's called marine reveement surfaces. So I get erosional surfaces inside of these valley fills, sometimes mistaken for kind of higher order sequence boundaries inside of there. But really what those are time successive reveement surfaces that now backfill the canyon with more marine influence stratigraphy that can either be tidally, river, or wave influence fill inside of the accommodation created. So very often you will see that motif of fill of more fluvial in the base and more kind of estuarine to deltaic towards the top associated with these internal reveement surfaces. So again, Not always the case, but very often you see a lot of these internal servers inside these valleys as well.
Yeah, fair enough. So, not naming names or saying anything specific, but I've heard controversy about incised valleys in general. Why is that?
Yeah, and this is a great reason to kind of make a video. And, a lot of the what's called the controversy around incised valleys really arise from the fact that I can have other kinds of incisions that give me the recognition criteria of truncation below and onlap above associated with sequence boundaries. So the question then becomes, okay, are these other processes, do you call those incised valleys as well or not? And I would say, no, let's not call things incised valleys that don't have a sequence boundary associated with them, but they might have geometries that look like that. And that's really where the controversy arises is not so much do they exist. It's like, yeah, they exist and they are the basis of sequences. But there are a lot of other features, particularly in a depositional profile of a clastic nearshore cliniform that can give you a false impression of incised valley. So a few examples of mistakes, not so much mistakes, but misinterpretations of things that seem to be incising filled with fluvial that people associate sequence boundaries are, the most obvious sort of the rookie mistake is doing lithostratigraphy. So if I had a whole bunch of wells, and this typically happens with well log correlation, where I see fluvial fill, I'm just connecting all the fluvial fills. And as I go facies transition into the delta plane and the delta front, I'm losing that. So I could almost create a smiley face that connects up all the fluvial fill. And basically what I'm doing now, I'm cutting through timelines. I'm not making a chronostratigraphic surface. And I'm definitely not making a surface at the base of a depositional sequence. So be aware if you're doing well log correlations that you don't do that. Probably the most common kind of dispute about whether something is an incised valley or not is when you see incisions in the delta plane that have truncation below and onlap above. And the question then is that truly a base of a sequence boundary? Are those just distributary channels that exist within this depositional environment? So a lot of times we'll look at outcrops and we'll see relatively small incisions, and those could just be distributary channels that are just filling in a high stamp within a depositional sequence. And then the last one that sometimes you'll see people mistake for incised valleys or sequence boundaries are large mass-wasted scars in the upper part of the slope. So we can get big canyons and they can be backfilled with coarse plastic material. So they can have the impression again of they have truncation and they have onlap in them, but they're not associated with relative sea level fall and an incised valley on the top sets. They're just isolated mass-wasted event that can be backfilled with things that look like little embedded low stamp sequences. So those are probably three things that tend to confuse people, and people will call them incised valleys. And again, I would probably not use that terminology unless that is really a mappable, regionally mappable surface that's associated with a sequence boundary that's indicative of relative sea level fall in your depositional sequence.
Copy that.
So um, with that, let me hand over to Brandon to kind of talk through kind of a candidate incised valley fill and kind of walk through that a little bit.
Okay, so a good example of a candidate incised valley fill comes from the Tulloch sandstone member of the Tulloch cyclothem in southwest Ireland. And so it's one of a series of cyclothems in southwest Ireland. But what's interesting about this is we have this really nice exposure in an inlet that goes from south to north along the coast. And we can get a really nice three-dimensional view of this candidate incised valley fill. For another example of incised valley fills that you can see, Dr. Anton put up a nice video on how he went through an exercise of identifying a candidate incised valley fill there in the Tusher Canyon in Utah. And so now moving on to the model. So here is our 3D model of the outcrop. Just to kind of set the stage, we're looking for sediment facies, stacking patterns, and stratal geometries that might help us better understand, is this an incised valley fill? So to start with, having been there, we know that there's a darker gray sediment. This is fine-grained mudstones. This lighter buff-colored sediment that's a bit more resistant, this is coarser-grained sandstones. And so what we can observe here, just like zooming out, is that we can see this general gradual transition from fine-grained, thinly bedded sediments, mudstones, transitioning into thicker bedded, more coarse-grained sediments, sandstones up here. So we have this coarsening, thickening upward motif, the stacking pattern that we see. We can also see that generally they're laterally continuous all the way around. In fact, if we look on top of this thick sandstone here, this is very laterally continuous. This forms this nice bench all the way around this outcrop. On top of that, if we zoom in, we can see another similar stacking pattern where we go from fine, thin bedded to coarse, thick bedded motif. And then zooming in here, we see that repeated again. This time, maybe a bit more fine-grained material in there, not quite as much thick sands. And then finally, on top of that capping, we see this thicker, fine-grained white mudstone. It's very thinly bedded. And on top of that, we see a dramatic change and transition into this dark orangey brown sandstone with very little fine-grained material in there at all. So zooming back out, looking at this overall outcrop, we can see that the base of the sandstone is not uniform. We see that it comes down towards near the top of this sandstone here, on the top of this this package. And then as we move laterally to the right, we can see that it steps up, revealing more and more of these subsequent packages. So if we take a quick little measurement from the top of this sand unit here, all the way up to the base of the sand, we're about 10 meters of erosion at the base of this sand. So what that tells us is that this is cutting into the older sediments, these more uniform sediments that are probably associated with a marine, perhaps deltaic environment. When we look internally to this thick sand unit, what we can see that it is a bit different than what we see below. It's a little less well organized. There's a lot more internal erosional surfaces, truncations, onlaps internally. It's not laterally continuous. If we kind of zoom into this face here, which is a bit perpendicular to the main outcrop, and if we look closely, we can start to see some inclinations of some of these beds dipping towards the left. And so, whereas if we looked at kind of the main view, other main view, we see a lot of smiles and erosions. Here we do see some inclinations to the left. What this could be is these could be dunes within bars, fluvial bars. So what we're probably seeing here is a thick fluvial succession, even with a lot of internal erosion on top of this marine environment, this marine setting. If we look back into the inlet cut, we can see that on top of this fluvial sand, we again return to some of this more well-organized, fine-grained mudstone with thin sandstone beds in there. So we see that again, that same stacking motif, that coarsening, thickening upward motif repeated again. So just kind of zooming back out to the overall outcrop, we have this overall stacking pattern of coarsening, thickening upwards, then some thinner coarsening, thickening upward successions, followed by a thick erosive fluvial sand unit, capped again by coarsening, thickening upwards, marine deltaic sediments.
It's a lot of fancy words, sir. What's the verdict then? What do we think it is?
All right. Well, let's kind of make all the observations, put all the observations that Brandon made, kind of put them together. So you guys can see that now. So, as Brandon kind of pointed out, we see probably marginal marine deltaic parasequences below this unit. And then we see a package composed of fluvial channel fills that internally filled up of bar forms, internally made up of cross-stratified sandstones kind of heading towards the east in here. Now, in terms of a single outcrop is always, or single well lock, or a single small area of seismic is always a candidate surface until you've mapped it regionally, right? So some of the things that make this a really good candidate surface, so there's a few sort of a checklist that you can kind of go through. The biggest thing is what we call basinward shift in facies. So I see, much more up dip facies sitting right on top of much more down dip facies without a natural facies transition. And that's definitely something you see here. So these recessive marine mudstones are probably associated with more of a pro-delta depositional setting, are being overlain by thick stacks of fluvially dominated sandstone. So I'm missing several facies associated with a delta front and a delta plane in there. So that's a good check mark, missing facies. Um, Size matters. So if we can see something that erodes, not just a meter, but we're talking about in this outcrop already more than 10 meters, as well as something that exists over a distance of several hundred meters, if not kilometer scale. It's a very good candidate surface. If it was just a distributary channel, you might maybe get a meter or two of erosion, and these distributary channels are not very wide. So this is a thick amalgamated channel belt with at least 10 meters erosion in the outcrop. So check that. In terms of the order, sequence stratigraphic order, what do we expect above the Incised Valley fill is transgressive mudstones above it. And again, above this, we see that marine mud. So those are all kind of good checks to say, okay, this is a good candidate surface I want to map around regionally. A couple of things that are maybe a little bit less in here is that it's kind of peculiar that the stacking pattern below us, while initially being progradational, becomes retrogradational before we see the sequence boundary. So it doesn't have the very typical feel of eroding into an underlying high stand, but obviously, that can be quite variable. So that's just something to think about here. In terms of a typical infill pattern, we do see several bigger surfaces, erosional surfaces inside of them that could be associated with marine revealment, but it's all fluvial, kind of stacked, really braided fluvial fill all the way through. So it lacks a little bit of that sort of that transgressive fill associated with more estuarine or deltaic fill towards the top. But good candidates. Now, obviously, people, Andy Pullum in particular, has done a lot of work here correlating this around to demonstrate that, yes, I can trace this surface much more regionally, and it's got quite significant erosion associated with it. So I think this really is an incised valley fill personally. Um, why do you care about incised valley fills other than, okay, I can use it to build sequences? What do I do with that? Well, incised valley fills themselves are really prolific reservoirs. They can have very high resource density because they can be thick over very small areas. Great top seal, often sealed by marine shales. So as long as I can come up with lateral seal, I can come up with really good plays in here. A really prolific incised valley fill play is the Abu Mahdi sandstone associated with the Nile Delta. These are sand systems associated with the incised valleys that form because of the sea level drop associated with Messinian salinity crisis. In fact, if you went to look at a map of the oil and gas fields of the offshore Nile Delta, you can map the incised valley fill because all these fields follow basically the incised valley of the system. So it's a pretty cool way to kind of see the geology expressed at that scale. So very prolific. What's cool here is it's also got a low stand van. So it's classic. It's got a low stand van that formed first and then it's backfilled into the incised valley. A low stand van obviously is a very good reservoir system as well, so no problem with reservoir. But unfortunately, there's no fields associated with that. Shell and Exxon drilled a number of wells here in the late 90s, early 2000s. Found plenty of reservoir, but really no hydrocarbons. And the big problem here, if you do the regional work, is that the salt that sits underneath this incised valley fill is present in the basin, but pinches out before I get to the more onshore part of the incised valley fill. So the incised valley fills have got access to the deeper source rocks, so the charge, whereas out in the deep water, the low stand fan that sits on top of thick halite does not have access to that pre-salt source rock, so it becomes a charge issue. So both in the low stand fan and the incised valley, very prolific reservoir systems. But obviously, you need to put it together with the whole sequence stratigraphic model with source rocks and seals as well to kind of figure out if this is going to work for you or not. So, devil's in the details. But I think this is a very good candidate, especially with the 3D model. You can really make some observations here that it's very hard to make in the field because it's quite a steep and narrow cut. So it's kind of hard to make the observations. So some of the observations that we can make in a model, we wouldn't be able to make in the field. So it's been really useful to kind of decipher this one.
Awesome. Fantastic. Well, thanks for the explanation and the insight to both of you. For anybody watching this that is interested, The models are from the field. We have a lot of them, and we have a lot of them all over the world. So primarily we use those in our field courses. But if you're interested in learning more, send us an email. We like sharing information. Renee's a genius. Brandon is too. So thank you guys both, Renee, Brandon, for your insights. And we have a couple more of these videos planned. So if you got to this one from another one, we'll see you on a different one, or stay tuned for more. Thanks.
All right. Thanks, everyone.
Thanks.
Adios.